you have gone through these problems. So let me start. So for this problem that's determine economic life, I think you have one similar problems covered in the homework, but this should be a really very similar setting, but the different context. But that doesn't matter. So based on the description on this in this paragraph, I just organized this information to a table on the left down the description in the table. So the initial investment here is 12,000 for the challenger. So I just transferred that to the capital recovery. So at the first year, and for the annual expenses for 3 years, we don't have anything there. And starting from the 4th year, we have the 2,000, 5th year 2,000, and 6th year 4,500. And we don't have any salvage values for the entire period. And now, since we don't have this useful life for this challenger, we're gonna, so that's why we're gonna determine the economic life for this challenger. So for this problem, it will be very straightforward. We're just calculating the UAC, or the annual worth. So we just do that year by year, and we first look at year 1, and the UAC for year 1 that would just be, since we only have the capital recovery, that would be 12,000, and we transfer that to the annual worth, so a given P, and we have 10% and one year. So this will be 1,3,200. And year 2, since we don't have anything in year 2, so the annual worth starting from year 1 to year 2, that will be, we're just still taking the capital recovery amount and a given P, 10%. And since we have 2 years, just put 2 there. That would be 6,914. And that for year 3 and year 4, and that's just a very similar pattern. We still keep this this given P and just change the years in the factor. So for year 3, that would be 3. For year 4, that would be 4. Then we will get year 3, that would be for 8, 2, 5. For year 4, that would be, oh, sorry, that's only for year 3. Year 4 is different. Yeah, so since for year 4, we have the annual expenses, well, we just need to convert that annual expenses to this annual worth again. And remember that we calculate this UAC, so we need to take all the annual expenses to the present worth first, and then let that back to this annual worth. So here we have 2 parts. So I just put four, so 12,000 a given P, 10%, that's 4 years, and we have the annual expenses, that's 2,000. So we first take that back to the present worth, so given P given F, oh, great, and then 10%, and it's year 4 years, and then we will transfer that to the annual worth. So we have a given P, and that's still 10% and 4. And we will get that's this number is 4217. And for year 5, that's exactly a similar setup, unless we have we just have the numbers in the factors get changed. That we just change that to 5. So I don't write out everything. Just change that to 5, and we should get that number equals 3854. And at year 6, that's just the same idea, but we have different annual expenses, which means we still get this guy copied down, just change the years to 6, and plus the annual expenses here would be 4,500, and all the factors are the same unless year to the 6th. And then we have the annual worth of the 6th year would be 3937. So since we can observe this annual worth is firstly going down from year 1 to year 2 to year 3, year 4, and to year 5, and it goes up to at year 6. So basically like this shape from year 1 to year 5 and 6 goes up. So this one will be the answer to this problem. So the economic life of the challenger will be 5 years. This will be just a warm-up for today's first question. So I think it's very straightforward. Do you have any questions? Yeah, but thank you very much. I appreciate that. Yeah, please remind me of that. That's really important. But yeah, I think because I just missed the previous recording part, so I just might let me re-elaborate. So to calculate the EUAC for the challenger at the first year, we first calculate the capital recovery part. We first turn the 31,000 to the present worth using the P given F factor, and using the market value as the year 0 minus that value, and as a whole piece, we turn that to the annual worth, and using the A given P factor. And we also note here, when we multiply the A given P factor by the P given F factor, that will just be the A given F factor. So if you want to use A given F factor, that's actually equivalent. But just remember, you always want to get the annual worth right. And then the next piece would be this annual operations management cost. So we have this 10,000 piece times P given that, transfer that to the present worth, and then turn that to the annual worth. So multiply by the P given F factor and then the A given P factor, and we have this UAC for the first year. That's 27875. And yeah, that's for that. And let me continue if you don't have any other questions, but just interrupt me if you have any. So now we are calculating the UAC2 for the challenger. Now, so still, since doing this way, capital recovery first, and then the annual operations and management cost, I think that sounds more naturally easier to track. So I will just following the same pattern. So for the second year, we are still using the year 0 market value minus the market value at year 2, but transfer that to present worth first. So that's 25,000 times this P given F factor and 15%, 2 years. And then we further turn this to the annual worth, so we need to times a given p factor. Just the same thing, so 2 years. So that's for the capital recovery. And then we turn the annual operations cost to the annual worth. So that would be the 12,500. Then first turn to the present worth. P given F, 15%. Then that's 2 years. Then a given P to the annual worth, 15%, and 2 years. Okay, then we are good. Have this equals 25677.33. Okay, so we are down for EUAC of 2. Since I think it's following the similar pattern, we should be good. And that's the first method. I want to show here, but just let you know, you don't have to know all the methods, but just show there's another method we can also solve this problem. So I'm going to introduce the total marginal cost method.
I have one question
Sure.
on the last calculation that you just did.
Mm-hmm.
On the EUAC for year 2, why is it that you took 42,500 minus the 25,000? Should that be, since it's the K minus 1 value, shouldn't that be 31,000 minus 25,000?
Because we are always looking at the, so I think the let me explain in this way. So so let's say if we want to use a challenger for 2 years, so we don't like you first use that for the first year and getting another one which have used the first year and then have used 1 year and then buy but it's like you're getting a used one for that. But instead we're trying to calculate if we use that challenger at the year 0, but we're gonna quit like at year 2. What's that gonna like? So that's why.
Okay, I see.
Yeah.
Okay, thank you.
No problem.
I have a question regarding the costs.
Sure.
We have to add the 10,000 from year 1, also the equation for EUAC2.
Can you say that again?
I think I'm looking at the equation
You mean,
for the present worth.
Oh,
Isn't the 10,000 missing? Because
that's right.
12,000,
So I think I just realized that. So that's I interpreted that. So Marisa, I think I didn't answer your question in the previous problem correctly. So right, I need to make corrections. So for the first one as well, we always wanted to include the previous. So annual expenses. So there should be cumulative annual expenses. So that will, for this one, I just don't go back. But for this one, yes, I think I missed that one. So we still want to add that piece back. But I think the solution should be right because I calculated in the Excel spreadsheet and used the formula. So that should be correct. But in the written way, I didn't include that. So that would be the problem. So yes, we need to include that, this guy. Yeah, so don't make mistake like me. Yeah.
The other
annual cost.
Expenses.
Right.
As you add them up.
That's right. So don't make mistake as I had. Yeah. Let's say I make a note here so people can see that. So we need to have the cumulative annual worth of the annual expenses. Yep, that's a great point. Okay, let me continue with the next method. So we are starting again to calculate AUAC for the challenger at year 1, but we are going to use the total marginal cost method. To see that more easily, let me put down that in the table again. So year 0, 1, 2, we have market value at year 0 for 42,500, 31,025, and operation and management cost, that's 10,000, 12,500. And then we have another column which should be the MVK minus MVK minus 1. It's kind of we can call that a lossing value, lossing market value. So we don't have that for year 0, for the first year. So we just take the difference of the market value of year 0 and market value at year 1. So use this guy minus this guy. We will have, that's 11,500. And we do the same for year 2, but we are calculating, because we're using K, market value at year K, minus market value at year K minus 1, so we use 31,000 minus 25,000, so this entry would be 6,000. And the next guy will be, we call that, it's just I times MVK. You can call it as cost of capital. So the interest rate here, the hurdle rate is 15%. So we use this times the 15%. That would be 6,375. And I think I made a mistake there. That should be market value at K minus 1. Yeah, we can go back that. Yeah, so in the formula we have seen that's interest rate times the market value at year K minus 1. And for this guy here, we still use that, but this is 31,000 times 15%. We should have 6,450. And we have the total marginal cost should be, so we have this capital, this market value difference of the market values plus the cost of capital, and then plus this annual expenses. Then we will have our total marginal cost. That would be the same actually as the EUAC. That's 227,875. And for the second year, that's going to be 23150. Okay. Then the next step, we use the TC, the total margin cost calculate, and we use this formula to calculate the EUAC. So the EUAC for the first year, that would be, so we only have 1 year there, so we only have one total marginal cost. That's gonna be 27,875 times the P given F factor. So P given F factor to the present worth. 15% 1 year, and then turn to the annual worth given P 15% 1 year. But maybe you observe that two factors can be combined. So you can, as long as you get the answer correct, there should not be any problem. Then this will be exactly the same thing we obtained before. Okay, this is straightforward. But for the next year, still using the total marginal cost, but remember that's a summation there, and we want to have this first year part. Actually, yes, the first year part. So P given F, 15%, 1 year. Just a bracket here, and then the second year will be this. So the total margin cost at the second year 23150. Turn that to the present worth P given F, and 15%. But it's 2 years here. And then together we turn that back to the annual, transfer that to the annual worth, but we are looking at year 2, so we multiply that by the A given P factor, 15% year 2. And we will have exactly the same number we got before. Let me... Okay. Yeah, do you have any questions until this step? So both methods should work equally, as long as you feel more comfortable of using any of those methods. And for the homework problem, some of the homework problems, we are exactly using the similar method. It should be very straightforward. Okay, so if you don't have any question, let me proceed to the question this problem asks. So it's really asking, when should we replace this old machine? So now we want to look at the defenders part. And if you have checked out Professor Johnson's video, here what we really want to compare is the EUAC of the challenger to the total marginal cost of the defender. So this step we'll want to do is calculate the total marginal cost for the defender. So let me list this information out here for the defender 102, 101. Market value is 25,000, 17,000 year 1. Just let me do that 1 year by year. So then that's this operations management for 15,000. And the market value, the difference of market value, that's that's this minus this guy. And then what we have, that should be a 0. Is the cost of capital, or the y times mv k minus 1. That would be 15%. I just put down the number here. At the total marginal cost, we just add these numbers up, and that will be 25,750. And from the previous result, we got the minimum EUAC of the challenger. So what we want to compare is the minimum of the EUAC from the challenger to the total marginal cost of defender, and year by year. So we are actually comparing the EUAC2, this one, this number, to the total marginal cost of the defender. So from exactly actually at the year 1, this guy is from the defender part, but that's actually larger than this EUAC at year 2 for the challenger, which is 256.77.33. That's the EUAC. That's minimum EUAC for the challenger. Since this number is already larger than the EUAC of the minimum EUAC of the challenger, we don't need to proceed to calculate the second year, and we can just make the conclusion, since the minimum EUAC of the challenger is less than the total marginal cost of keeping the defender at year 1 for additional year.
I think your screen is still frozen, like towards the beginning of inputting the information on here. I haven't been able to follow what you're writing right now.
Oh, thanks for letting me know.
Yeah. I see
actually,
the
where can you see?
01 and
let me. So any other of you can see my screen? Is that freezing? Let me see.
Yeah, I have the same problem.
You have the same problem. Okay. I don't know what's going on, but I'm sure the recorder is working. But so it's still not working? Like, so still freezing?
And maybe if you just scroll to the right so we could see the rest of what you've written.
Oh, didn't see that.
Updated.
Okay.
There it is.
Cool.
It's showing.
Okay, that's good.
Could you kind of walk us through that again, because it was kind of freezing up as you were going through it earlier?
Yeah, sure. So which part you didn't hear? Okay, so let me. So
I think I lost you after you were calculating the I times MVK minus 1.
So for the defender, right?
Okay.
Right. So yeah. So previously we are working on calculating the total margin cost for the defender. So we calculate each component. So these guys are from the problems. So first guy is the loss in the value, so loss in the market value. So we use market value at the previous year minus this year's. We get this 8,000 from that. And then the second one would be the cost of capital. So that basically is the interest rate times the hurdle rate times the market value at previous year. So we use 25,000 times 15%. And then we add up all these ingredients. So annual operations and management cost plus this difference in market value and this cost of capital. And we get this total margin cost to 5750. And then we compare this total margin cost with the minimum UAC of the challenger we already have. And we already have this inequality. The total margin cost of defender are already larger than the minimum of the UAC of the challenger. So there's no need to proceed the calculation, save some time, and we can draw the conclusion in the EUAC of the challenger, since that's less than the total margin cost of keeping defender for one additional year. So we conclude we should.
So for this problem, since the defender, so since the defender is just here for one additional year, is that why you don't convert the total cost to EUAC for this comparison then?
Yeah, I think for this type of problem, as actually if you have checked out Professor Johnson's video, I think we just compare the total margin cost of defender and with the minimum UAC of the challenger. So that's why I don't think we needed to calculate the EUAC for the marginal for the defender. Does that make any sense?
Okay, thank you.
Okay. Okay, so we have.
I'll just have to go look back at that.
Oh, what? Okay, so then we draw this conclusion: this old machine should be replaced immediately. Okay. Yeah. Do you have any other questions?
No, I did find that in my notes just now, so that makes sense.
Okay,
how
that's
we
good.
Did this.
That's good. Okay. So maybe let's go to the next problem. Okay. You might have some feeling about this problem that it's kind of similar to what we have done in the previous one. Yes, but we still want to determine when to replace the machine. But here we have the different configuration of the challenger. So we're in this one. We are given. Let me find my pen first. Yes, we are given the economic life of the challenger will be 12 years, and we can just use that for this calculation. So we are still starting from the challenger. So we're looking at the EUAC of the challenger. But this one, since we already know the economic life for the challenger is 12 years, so it's basically we calculating the annual worth of the challenger for 12 years. So the first piece, we have this initial capital investment, 30,000, and turn that to the annual worth, a given P, 15%. So, and that's for 12 years. And the next one, we get this market value at the year 12, end of year 12. So we want to, since we're calculating the annual worth of the cost, we minus that one, and you convert that to the annual worth, a given P, a given F, that's the future worth. So 15% and 12 years. And then we have the annual expenses as 16,000. And this equation will lead to 21,466. And this is the EUAC for the challenger. And then the next step is we want to, just like we will have what we have done for the previous problem, we can compare using this EUAC with the total marginal cost, or actually I think there could be two ways. The other way is, since this for the challenger we already know the years, we can also use the economic life of the defender of the defender to use that compare with the challenger's EUAC. So so what we can do for the first one will be this. We just let me put using the total marginal cost first. So put down the numbers for the defender, year 0, 1, 2, and for that's market value, that's 4,000, 3,000, 2,500, operations and management costs. That doesn't cost us, just any expenses. 20,000, 25,000. So we still calculate these guys. And capital recovery, I times MB, K minus 1. Yep. So that would be that's 1,000 for year 1 and 500 for year 2. So for this one, that's just 4,000 times point. That's 15%. And then that will be 3,000 times 15%. And we add up all these numbers. We have the total marginal cost for the first year. That's 2,600. And for the second year, that's going to be 2,5,950. And using the same logic actually for in the previous problem, this total marginal cost of this defender, this number, is already larger than the UAC of the challenger. So we will have the same conclusion, so that we want to replace this machine immediately. And if you want to check the UAC, that's fine too. So that's UAC for year one for the defender. Look, that's gonna be the similar logic. I think I don't need to put down the intermediate step. Do you want me to put down the intermediate steps? It's just following the same pattern. Just to save some time, I will just show the. You can tell me. So, but I just jot down the solutions first. So for the UAC at year one, that would be actually exactly the same one, same number as the total margin cost. That's this guy. And the UAC at year two will be 23622. And for the third year, that's 25713. Okay, then what we can see is the UAC is increasing, and the UAC for defender, the minimum UAC for defender is a year one, so we can say that its minimum, its economic life is 1 year, and we are still getting this UAC the same as the total margin cost of the defender, and that's greater than the UAC of the challenger. So yeah, let me write down our conclusion again. So we want to should replace the present machine immediately. And then we are done for this problem. Do you have any other questions? Just summarize again. So for replacement analysis by comparing like defender and then challenger, like asking the question like when we should replace this the defender. So I think it's better to always go from the challenger. We calculate the UAC for the challenger until we get the minimum of the UAC of the challenger, and we compare that with the. And then we calculate the total marginal cost of the defender and see, and we can calculate that total marginal cost year by year. So we can save some time to see until when the minimum UAC of the challenger gonna be less than the total marginal cost of the defender, and then we can determine when to replace the defender.
I have a quick question.
Sure.
How did you know that the EUAC that we calculated for the challenger was the minimum one? Because we just calculated after 12 years.
Oh, since here we are given this economic life of this challenger already been 12 years. So we can just directly use that. In the previous problem, we don't know, so we want to know when. We should calculate year by year. Just like try and error.
Okay.
Yes.
Thank you.
No problem. That's a good question. Okay. Okay. Let us continue. So we conclude the problems on the replacement analysis, and now we are going to the break-even analysis. So I just show one problem here, since I think the break-even analysis is much easier than the replacement analysis problems. Do you think so? Continue. For this one, since it's break-even analysis type of problem, so what we want to see is some type of worth equal, so some type of worth of this option equals another option, and we set that equal and find the unknown in the part. So in this problem, that would be these the miles. So how many miles do the tractors have to be driven per year before the wind shear deflectors force over the other deflectors, favored over other deflectors. And we want to calculate range. So on the range part, as long as we have found multiple that unknowns, and we can determine this range more easily. So that's actually very similar to the problems we have done at the very beginning of the course. You still remember we like using demand and supply to find some break-even point. I think that's a similar spirit. So let me go through this problem. So for this one, I think we're gonna use the annual worth or the UAC. But before that, let me put down some ingredients we need to get this annual worth. So for wind shear, we have wind shear, blow by, and air advantage. Okay, so here this problem asks us to on this how many miles do the tractors have to be driven per year. So we assume this number. We assume this has unknown, so x. So we put x miles per year. So for each one, since we're finding the break-even point, so for each one we will have that x piece. Yeah, so for all these part, I'm calculating the price per year, the annual expenses with the fuel. So for the first one, we have x miles per year, and I think that's 0.2 gallons per mile, because that's 5 miles per gallon. I just use 1 divided by 5 and use that unit. It's easier. So 0.2 gallons per mile. And the price, that's 3 gallons. And this will be the same for all of the other options. So just me drop down. I just ignore the unit here, but it should be clear. And there's in the other part a bit complexity on here. So 5% in drag reduction means 2% in fuel savings per mile. So drag reduction here is 20%, but that means 8% reduction in fuel. That means 4% for the blow by, and then that's 25, so that would be 10% reduction for the air advantage. So another way to write is 20% divided by 5% and times 2%. It's just a similar pattern across these guys. And then since it's a reduction, so what we have is for the wind shear, that'll be 1 minus, just let me write out that again, times 2%. So that's what is left for the few. And for the second year, that would be, for the second option, blow by, that's 1 minus 20%, that's 10%, 10% divided by 5% times 2%. And this one will be 1 minus 25% divided by 5% times 2%. For the first guy, that's 0.92. For blow by, that's 0.96. Right, and for this guy, that's 0.9. I should make it small.
I have a question on the beginning numbers that you have for these equations.
Okay.
Where did the 0.2 gallons per mile and the 3 gallons, where did those values come from?
Okay. So I think this one is from here. Is that right? So 5 miles per gallon. Just do some conversion. You use like 1 divide. If you convert that to gallons per mile. So basically, you just do 1 divided by 5. That's 0.2. Yes, and that's, I think the other part, fuel cost expected to be for, yes, I think I dropped down the wrong number. For the price, that should be $4, right? $4 per gallon. That's gonna be 4.
Okay, that makes sense. Thank you.
No problem. Thank you for the question. Let me check. I think we're still getting. Yep. Okay. So, and then, right, just recalculating it. For this guy, that would be 7.37636. Let me check if it's still right. Quickly. Okay, yeah. So this should be right, and then there's an X there. So and then this one will be 0.768x, and for this one that would be 0.72x. That's dollar per year. Now we have the key ingredient for calculating annual expenses, and we can proceed to calculate the annual worth. Okay, either put EUAC or annual worth, that would be fine. So for the first guy, it's wind shear, starting with the capital investment, because annual worth, a given P, 10% hurdle rate, and life of year, useful life 10 years. Then you have the maintenance cost per year, that's 10. That's already in the annual worth. And also this last piece, the fuel cost. So that's what we actually have just calculated. We just drop down the numbers here. So for the wind shear, that's at 0.736x. So this part, we will have 172.7 plus 76x. And And then go to the next one. So the annual worth of blow by, that's capital investment 400 convert to annual worth. And the maintenance per year, that's 5. It's already in annual worth, and this blow by fuel costs 768x 768x. So we have 7.08 plus 0.768x. Then the last one, annual worth of air advantage. So 1200 annual worth, a given P, 20. That's 10%. 5 years for this guy. Same maintenance cost 5, and the last fuel cost, and we have 321.56. And what we will have is, so the next step, since we already get the annual worth equation set up for each of the option, the next one we want to get the break-even points. Basically, we just set the two options equal, the annual worth of the two options equal pair by pair. So we can first set the annual worth of the wing shear equals the annual worth of the blow by. Yeah, to save some time, I just don't drop down these numbers exactly here, but from this setup, you will get X approximately about 3207. That's for the first pair. For the second pair,
I think it's frozen again.
yes, I just received another warning from WebEx. I don't know if any other people are doing the problem session for other classes. It's kind of getting this congestion problem. So did you miss any part? Can you see the screens moving? Is it good for now?
Not right now. I think it's still frozen.
It's still frozen.
Back on the calculate.
Okay. That's. But we are close. We are close.
For the,
don't worry.
the last air advantage one.
Okay. Let me see. What's the problem? My connection is good. I'm still thinking maybe it's the server problem. But let me type here.
That's probably true.
Yeah. The WebEx is...
Oh, there we go.
Oh, okay. That's good. Thanks for letting me know. Yeah, so did you miss any step there?
I think just whatever the totals for the EUAC is.
Oh, this one? Mm-hmm.
And then kind of just explaining. Yeah, I think that's fine. I could do that on my own. But
yeah, just let me re-explain of these.
Here.
Yeah, let me go through the last one again. No problem. Yeah, so this one is we calculate the annual worth for the air advantage. We have 3 parts. This one, the capital investment, we take that to the annual worth. So we use capital investment times the A given P. And since it's 5 years, so that's the first part. And the second part would be the annual worth. So it's the maintenance cost per year. So it's already annual worth. So we just put 5 here. And for the last piece is the annual fuel cost we have already calculated previously. So we just drop down in this, and that's the setup for the annual worth for air advantage. And then we have this derived. Is that okay?
Yeah, that makes sense.
Okay, cool.
I do have one question
Sure.
though on the parts where you calculated the 0.72x and 0.768x. I'm wondering why you do 1 minus the 0.9 or 1 minus 0.96, since I think since they're saying you have 2% in fuel savings, I would be inclined to, instead of 1 minus 0.96, use 0.96, because that's that's like the amount that you're saving on it. So the greater value would be the actual cost. Like the 0.96% of that is like what's remaining in cost, right?
So, in this side we are calculating the percentage of saving, right? And so 1 minus that should be the percentage remaining.
Oh, I see. The total that you have 1 minus that percentage is, you're saying 0.92.
Yeah, the total will be.
I just, for some reason, got different numbers.
Yeah, but, so that's the whole thing will be 0.92.
Okay, that makes sense then.
Yes.
Thank you.
Yeah. Thank you for raising that question.
Thank you.
Yeah, no problem. Okay. Yeah. What about the other parts? Okay, so let me continue. Yeah, we are in the step of calculating the break-even points. So we set equality between pairs of the annual worth of different options. So we have just covered the annual worth of wind shear equals the annual worth of blow-by. So now let's do the annual worth of blow-by equals annual worth of air advantage. Yeah, we just I just skip here, but you can, to calculate the x, you can just drop down the numbers and set them equal, and you should get this x now will be 5,239 miles per year. And the last pair, that would be the annual worth of wind shear with annual worth of air advantage. And still the same step, we will get the break-even point. That's 9,304 miles. Okay, and I think we have all the ingredients ready. So to answer this question, so let us read the question again. So how many miles do the tractors have to be driven per year before the wind shear deflector is favored over the other deflectors? Over what range of miles driven per year is air advantage of the best choice? It's actually, we just use these break-even points to build up this range. So we have 3 points, 3207, and it's 5,239, 9,304. So this part is where wind shear equals the annual worth of wind shear equals that's blow by And this guy would be where the blow by equals any width of blow by equals the air voltage, and here is the where we have the wind shear equal. Oh, that's blow by air voltage is wind shear and air voltage. So when do we select blow by? Is actually we can compare these two. So blow by is selected actually when so this might not be that straightforward. I think I may better have another step. So it's better to draw some graph and to show this. That makes things easier, but I didn't. But let me try if I can draw the graph nicely. So we have point. It's 172. So for any worth of wind shear, that's 172. We have 1 point that's 70. 70. And that's 1, 3, 3, 2, 1. Just don't draw the exact thing there, but so the line would be 0.7. It's a little bit flatter, so that we draw the any worth of blow by's line will cross this point. Any worth of wind shear will go through this point, and any worth of air voltage will go through this point. I tried to draw the graph, the figure, to show the range. I think that makes comparison, finding the range, much easier. So I forgot to draw this graph earlier, so please bear me, take some time. And $70.72. X equals probably so X for wind, wind shear. Blow by wind shear. That should be some 3, 2, 3207. Air advantage. So air advantage is with wind shear. Yeah, please bear me. This is not a good good drawing, but should be enough. So this is the cross. This is air advantage. This line is the wind shear, and that intersection is 9304. And we have this blow by, and this guy is wind shear, blow by and wind shear 327. And this line, that's air advantage, and blow by that's 5239. Okay, so yeah, since it's the line represents the annual worth of the cost, basically larger means the more costly. So whenever the area is below, that's the area that we would prefer. So first, when to select blow by. So we can see this area. So blow by is this line. So this area, blow by has lowest cost in one the x values is less than or equal to this guy. So when you see that, if it's beyond this 3,207, the cost goes up, and from this point on, the wing by will be the least costly, and and go up there, this blow by will be the most costly. So the blow by will be when x less than or equal to 3207. And then what is the range for wind shear? That's basically for wind shear, that's this area. Since we have this line is the lowest in this segment. So that's why we will have the range that's an interval. So greater or equal to 3207 and less than or equal to 9304. And this is for wind shear. The last one is for air advantage. So air advantage is actually this line. Yeah, this is a bad drawing, but it's not a very straightforward, very strictly straight line, but just treat it as a straight line. So this part is where will be the least costly for air advantage. So that would be x greater than or equal to 9304. So that will be, I think, will be the conclusion for this problem. Otherwise, if you don't want to draw a graph, you want to just use the mathematical formulations to calculate these ranges. it's fine. You can just use inequality sign on there, but remember where you should always notice which sign you want. So keep the consistency there. If you want to calculate the range for EUAC, the range for like the anywhere of the like wind shear option. So always want to use that less than or equal to the other guy. So either the blow by or the air voltage, and you should get a range. And it's just the same thing for the others, and we'll get another two ranges for another range for each one, and that will be the calculation part. But using graph is just takes some time to draw a nice thing, but it makes explanations just easier. Do you have any questions?
I don't have any questions. This was helpful though. Thank you.
No problem. Thank you very much for waiting for me to draw this graph.
No problem. It was helpful.
Thank you.
All right. Have a good night.
You too.